Good evening, everyone. Um, I do not know if Josh will show up, but just in case, I'm starting my Hangout now. So until he shows up, I will talk to the people who are in the chat. So if you're in the chat, please introduce yourself. I see we have Rob and Hillel Finder. Thank you for showing up. And it looks like we have a few other people present too. So if you'd like to introduce yourself, we can talk for a while I wait for Josh to either show or let me know that he won't be showing. This hangout was arranged 2 days ago. I said I would be available late Tuesday night, and he said it should work out. So I sent him the link to the hangout. So hopefully he shows up. But if not, we can just talk for a bit. So, good evening, Nim. Good evening, Soundly. And hello again to Hillel and Rob. So if you're not familiar with Josh, I've posted two links here in the chat. One is to his YouTube channel. He goes by Josh Walker and also by UberFlatEarth. And I also have a link with a timestamp to him on Steve McRae's show last week. He was the second act. Debbie was the first act for about 90 minutes. And then he had the show for about another 90 minutes. So good evening, Sue. Thank you for showing up. So I might as well show you a bit of my correspondence with him to explain why this hangout is happening. Probably can't show it without showing my email address, so I guess I'll just describe it for a while. On one of Josh's YouTube videos, probably the third most recent one, Chilly Flat Earth Triggering. Good evening, Rob. Good evening, David. Oh, I already said hello to you, Rob. So on his Chili's Flat Earth video, he's talking to someone, and he uses an argument that he uses in a lot of his YouTube videos, where he says that seeing Venus in a dark sky shouldn't be possible on the globe model, and especially being able to see Venus or Mercury and then planets that are further out from the sun than the Earth. For example, seeing Mercury and Jupiter, or seeing Venus and Mars next to each other in the night sky. So I responded to him, showing him simple solar system models, two-dimensional models, that show it is actually possible for this line of sight to occur. And he can't really type right now. He's injured his hands recently, so he'd prefer to do this via voice rather than via email. So that's why I said we could do a hangout, and hopefully we get to do this hangout tonight. Otherwise, I get to entertain all of you with stories of the heliocentric model and evidences that we have for a spherical and not a flat Earth. But I'm pretty sure I'd be preaching to the choir if he doesn't show up. So we'll give him a few more minutes to show up. I guess probably till 15 after the hour. I'll send him another email shortly. Otherwise, I guess I'll call it a night around 11:15. So that's in about 10 minutes from now. So while I have your attention, let me do a screen share and let me show you some of the Nim. You could invite Grayson. If you were to get me, if you were to send me a message with Grayson's email address, or maybe I could send you the invite via Discord. It would be interesting to have a structured conversation with her. I would be very interested to know if that could actually happen. So you let me know the best way to get in touch with her. Um, I mean, you can just message me in Discord if she's online right now or something like that. Uh, yeah, if he doesn't show up, I would try talking to Grayson for a while. Excuse me, I'd try talking to Grayson for a while. Um, so first of all, this is Solar System Live. This is an online orrery hosted by Formulab. This is the one that I used to produce the images that I sent in my email correspondence with Josh. And you can see how it works. And I'll put the link in the chat for all of us. There's also this browser JavaScript-based orrery, and it's hosted on GitHub. If you do a Google search for JS orrery, you'll find it. And I'll post the link for that in the chat here as well. And of course, you should all know and be using Geogebra. You can use it in the browser or you can download it onto your computer. Geogebra is very good for making 2D and three-dimensional models where the objects you create can be based on mathematical equations, or you can kind of draw them freehand and whatnot. So as you can see here, I've made a couple dozen GeoGebra models. This one here, for example, the moon and sun line of sight. The purpose of this is simply to show that because of the moon's 5-degree orbit, 5-degree orbital tilt, it's perfectly possible for people to see a full moon because the moon can be above the Earth. And so the moon can be in the full light of the sun from the dark side of the Earth. So you can be on the dark side of the Earth looking at the moon, and the moon can be fully illuminated. This is why not every full moon happens to be a lunar eclipse. And this is also why every new moon is not a solar eclipse. So I definitely recommend using GeoGebra. I know people like GeoStreamer use it. I think I found out about it through GeoStreamer. He didn't mention it to me, but I saw him using it in one of his videos, and it's just a very useful tool. So if you ever have conversations with flat earthers or you need to draw quick models or whatnot, I definitely recommend using GeoGebra. All right, so Josh has about 5 more minutes. I'm pretty much no longer going to interact with Nathan or Riley. Watching their show only gives Nathan views. And the more comment discussion that happens on his video, the more views his video gets. So I won't be interacting with Nathan or Anthony. Certainly not on Nathan's channel. Probably not on Anthony's channel. Arwen is not worth talking to either. Simply, the outlandish ideas, he must be thinking on a higher level. Is the most polite way I can think to put it. Now, whether that level is higher or whether he is higher when he's on that level, I can't really be the judge. But I basically don't see the point in trying to interact with him. Good evening, Brain Grunt, and good evening, Andrew Eddy. Welcome from down under. I have a sister who's currently living in Australia. So sometime I will try to employ her to get some footage of the southern celestial pole. I'll go visit her probably sometime next year. Um, I have no idea. It muted me. My own Hangout muted me. I'm really sorry about that. Sorry about that. I just spent I just spent like 5 minutes talking about Anthony Riley and magnetism. I'll save that for another time. Um, all right, so I don't have confirmation that Josh is going to show. Um, so what I will do instead. Okay, so what I'll do instead is I'll introduce myself and just give a bit of my background. I will keep the audio on my YouTube very, very faint, just so I can make sure that the audio is still coming through. Um, so, my name is Jeffrey Pinion. I'm a 36-year-old from New Jersey in the USA. Um, my my college background, I have a bachelor's of science in computer science. I am a computer programmer and a database manager by profession. I work for a company that helps other companies avoid internet crime or internet criminals. Um, my interest in astronomy goes back to a very young age. I enjoyed looking at the night sky. I enjoyed watching meteor showers and looking at the constellations. Um, I remember from my youth a partial solar eclipse. I remember watching it from my front yard with two paper plates with a pinhole. Um, and it was during college is when I saw the most amazing meteor shower of my life. I'm pretty sure it was the Leonids. It was in November, and I went to college up near Albany, New York. So we drove like a half hour into Vermont. We went to a totally dark place, absolutely no light pollution around. And the meteor shower that year, it was maybe 2002 or 2003. The meteor shower that year was phenomenal. There were meteors that lit up the whole field that we were in. Um, it, it was it was the most amazing astronomical experience I've ever had. Um, a few years ago, I got a telescope, um, and I've since got a solar filter for it. It's the Celestron 70AZ. It's not a great telescope. It has a manual mount that I have to operate, and it's not great. It serves my purposes, which are basically to allow me to look at the moon, allow me to look at the sun. Um, I get decent views of Jupiter and Saturn and Venus. Mercury, I can see it. It's not great. Mars, I can see it. It's not great. But I am able to see, for example, the bands on Jupiter. I'm able to see Saturn's rings. I hope eventually to start watching for the eclipses of Jupiter's moons. Um, and I'm looking forward to the transit of Mercury, which should occur next year. And I hope eventually to live stream a lunar or solar transit of the ISS. Because I basically have an attachment where I can put my iPhone onto my telescope. Um, I drove down to South Carolina in August to watch the total solar eclipse. I brought my telescope and my solar filter. It was absolutely amazing. I hope I'm around to see the 2024 solar eclipse, which will be closer to me. Um, it was just about a 24-hour drive home from South Carolina. That was a pretty rough day. um, so that's me. That's my background. I went to a science and technology high school. So I had 3 years each of physics, biology, and chemistry. And I'm pretty sure I took physics my senior year also, because that was of the three sciences, that was the one I was most interested in. I've always had an inclination towards mathematics and physics. Physics, I feel, is like the purest mathematical science that was offered. I don't really have the interest in chemistry, and biology was not nearly enough about mathematics for me. Um, and I was a really good math student. I participated in the ASHME and the AME and the USAMO a couple years during my high school time. Um, any particular people who pulled me into the flat Earth debate? I got into flat Earth while I was preparing to watch the total solar eclipse. I was looking for videos on YouTube of previous solar eclipses, just like to prepare me for what I was going to see, to give me ideas of what I should be doing and looking for before, during, and after the eclipse. And I started finding these videos that claimed that the eclipse was a hoax, or the eclipse wasn't doesn't work on the globe model, and all these preposterous videos. And that was how I found out about flat Earth. I'm pretty sure the first videos I watched were like Mr. Thrive and Survive, um, probably Awake Souls back before they went crazy. I mean, Awake Souls used to not be as weird as they are now. Um, hang on, hang on 1 minute. Seeing if I can get a new person to talk with. So where in South Carolina? I went to Simpsonville, South Carolina. Simpsonville is towards the western end of South Carolina. It's kind of a suburb of Greenville. Um, I have a fraternity brother who lives in Simpsonville, so he invited me down to his house. He had a telescope set up too. Um, it was a good time. Uh, I should say, for full disclosure, uh, my college fraternity was founded by Freemasons. Um, you don't have to be a Freemason to join. I am not a Freemason, uh, but my college fraternity was founded by Freemasons. And also, in the interest of full disclosure, I am a Christian. I'm a Catholic. Um, I'm not one of those crypto Jewish Jesuit Knights Templar conspiracy Catholics that apparently are involved in the globe deception. I'm just a normal, standard Latin Rite Catholic. So nothing thrilling there. It was the first total eclipse that I saw. that I saw, and I can understand, like, having seen it, I can understand why people chase them. I can see why people will go halfway around the world to see a total solar eclipse. Um, it does not compare to anything else. 99% eclipse is nowhere near as amazing as a total solar eclipse. They differ in kind, not only in degree, for sure. Um, all right. Peace of Christ be with you, Andrew. All right. I've sent an invitation, an open invitation, uh, to Alt Earth, which is Grayson Sharp's uh, channel. Good evening, Inrem. Total solar eclipses are televised already. Um, but seeing it on the TV screen is nothing like seeing it in person. Um, the weather in Simpsonville was pretty perfect. Um, as I was driving there that morning, there was a bit of cloud cover that seemed to be rolling in. Um, but by the time the eclipse was actually starting, there were only like 5 minutes of threatening cloud cover near the sun. I don't think the sun was ever actually covered by clouds the whole time, from the beginning of the eclipse to just after totality. Good evening, Beach 8. INREM, why does it have to be NASA? And you can find a YouTube video of total solar eclipses. Like, I'm not going to search YouTube for you. uh, good evening, Ray. Okay, so somebody named Patricia Steer, probably not the real Patricia Steer, came in and muted me back then. That was amusing. Yeah, Malcolm, traveling from Australia to the US for an eclipse is quite the commitment. There are a few total. There are a few solar eclipses that are coming up between now and 2024. I think two of them go through South America, and a couple of them are like you can only see them from Antarctica. Come on, NREM. You know it's $52 million a day, not 20 million. Give them credit. I'm pretty sure Josh is not going to show up. So, good evening, Windows Vista. Um, I have a prediction to make about the next lunar eclipse, by the way. If you haven't heard my prediction about the next lunar eclipse, um, first of all, a total lunar eclipse will occur on July 27th. And my prediction about this eclipse is that if you are in the northern hemisphere, the lunar eclipse will begin from the bottom of the moon up. And if you are in the southern hemisphere, the lunar eclipse will begin from the top of the moon down. Um, that's just that's just my prediction, because a lot of flat earthers were pointing out that this most recent total lunar eclipse at the end of January, it looked upside down. It looked backwards. That in the northern hemisphere, the shadow on the moon was starting from the top of the moon and going down. Um, yes, July 27, 2018, total lunar eclipse. Only visible in the eastern hemisphere, though. Okay, also visible from some of the western hemisphere, but only in the south. Um, but yeah, so if you're in Western Australia, if you're in India, the Middle East, uh, Eastern Africa, you'll be able to see a total lunar eclipse. Yep, Eastern Hemisphere. Sorry. Right, ladies and gentlemen, I'm sorry to disappoint you, but my conversational buddy Josh is a no-show. It's been a half hour. I have work in the morning, so I'm afraid I'm going to end this hangout. Thank you for showing up. Oh, you know what I'll do really quickly before the end of the hangout? I was muted. I'll explain really quickly what I was talking about while I was muted, which was uh, Anthony Riley, magnetism, and the Southern Celestial Pole. Anthony Riley uh, was big on these maps and charts that showed the magnetic field lines on the Earth and also the magnetic declination, the deviation from true magnetic north and true magnetic south um, that a compass would show you in various places on the Earth. Um, he misinterpreted these maps, first of all. He didn't notice that the maps didn't show above 70 degrees north and below 70 degrees south. He didn't notice that the maps were not complete maps of the world. Um, um, and so he was basically saying that because you can't be sure your compass is really pointing towards the magnetic North Pole or the magnetic South Pole, you never really know what direction you're facing. And so you can't really be sure that the second celestial pole that you're seeing is really due south. It could be the North Pole for all you know, or it could be like a Western pole or an Eastern pole. So basically, I said to him, um, you can be north of the equator, and you'll know you're north of the equator because you can see Polaris. You can be somewhere on the Earth and see Polaris, and you can turn 180 degrees around so that Polaris is directly behind you, and you can begin walking in a straight line. And no matter whether it's a globe Earth or a flat Earth, if you walk in a straight line with Polaris at your back, you are walking due south. And you can use any number of techniques to make sure that you always walk due south, that you're always walking in a straight line. And eventually, you'll look back and Polaris will no longer be visible. And instead, as you continue walking due south, you will see a new celestial pole appear. And that will be the due south southern celestial pole. And so that's how you can know that there are two celestial poles. Um, Now, of course, we would say that that proves that the Earth is spherical. Anthony Riley will come up with any number of explanations for why two magnetic poles is not proof, two celestial poles is not proof of a spherical Earth. But that's his problem and not ours. Okay, so that's what I talked about while I was muted. Um, thank you all for showing up. And maybe I'll do another one of these hangouts when I actually have somebody to talk to. Um, so, good evening. Thanks for showing up, Sean G. Brain Grunt. Um, I can guarantee you that every one of my hangouts and videos I do will be non-vulgar. They will be family friendly. They will be polite. They will be courteous. I will avoid profanity insofar as is possible. I will request that my interlocutors not use profanity. I will not shy away from ending the hangout or kicking them out if they are rude and profane. I will be respectful. I will be calm. I will also be structured and orderly. We will talk about one topic at a time. Um, I was all ready to have a notes file open with the various things that we talked about so that if we had a side topic or a tangent topic to talk to, I would make a note of it and we'd get back to it later. But I find that too many of these debates are very haphazard and very scattered, and they don't deal with slow, careful, reasonable, logical discussion of a single point at a time. Which is not to say that I'm not capable of having complex discussions about multiple topics at once. I just don't think that that approach is beneficial in the flat Earth, globe Earth conversation. I think dealing with a single topic at a time is much better. Okay, Soundly. Yeah, before I go, I'll express the points I was going to make. In his videos, he tends to bring up the following issues. These are the issues that he brings up in his videos. He brings up observations of the inner and outer planets of the solar system in close proximity in the sky. For example, Venus and Mars near each other, or Mercury and Jupiter near each other. He brings up the curious incident of the presence of the sun and the moon in the sky simultaneously. He seems baffled by the fact that sometimes there is no moon in the night sky, and that sometimes he sees the moon in the daytime sky for several days in a row. He may have kind of flat Earth opinions on the location of the sun and the moon, as far as do we sometimes see clouds behind the sun? Um, he questions the legitimacy of the International Space Station. For example, he thinks that the way that astronauts' hair looks on the ISS is incorrect. Um, he questions gravity and the gravitational constant. He points out that Newton came up with his law of universal gravitation, and it wasn't for more than 100 years later that Cavendish did his experiment, which actually calculated a value for the gravitational constant. And he also mentions that later experiments keep coming up with a different value for the gravitational constant. And if the gravitational constant truly is a constant, shouldn't we always calculate it to have the same value? Um, he questions evidence of the curvature of the Earth, obviously. He's probably of the opinion that the horizon always rises to eye level, but I'm not 100% sure about that. Um, he questions the ability for rocket propulsion in a vacuum. He doesn't know how rockets could work in the vacuum of space. Um, he doesn't know how the sun could be a ball of fire if space is a vacuum, presumably because he thinks the sun is a ball of fire in the chemical sense of fire, much like fire on Earth requires oxygen. He probably is not aware that the sun's fire or energy comes from a nuclear reaction of the fusing of hydrogen atoms to make helium, um, and the nuclear fusion does not require oxygen. And then the last topic was questions about the magnetic field on the Earth, specifically in terms of the core of the Earth. Um, how do we know what the core of the Earth is made of? And if it's molten, how can it be producing magnetic field? Um, and I mean, my answer to that is, well, maybe the core of the Earth is molten, maybe it's not. But even if it is molten, while it is true that molten iron is no longer permanently magnetic, it can still be an inductive magnet, which means if there were a solid iron shield around it, that solid iron shield could still be a permanent magnet, and the permanent magnetic quality of the solid iron around the molten iron would induce magnetism in the molten iron core. Um, these are all topics I would have gladly talked about tonight had he appeared. Unfortunately, he didn't show up. So all I did is I showed a quick Geogebra thing that showed how the moon can be a full moon and not be in the shadow of the Earth, and that's because of the 5-degree tilt and the radius of its orbit. And I showed two orreries that I use, one hosted by Formulab and the other hosted on GitHub. Uh, and the links, I will put them one more time in the chat before we close up for the night. If the core is magnetic, why do compasses point north? Because the Earth could be treated as a dipole, as a standard rectangular magnet. Um, and the magnetic field that it produces has a north pole and a south pole. You can do a little bit of research to find maps of this. What's interesting is that what we call the North Pole, because our compasses point north towards there, um, the North Geographic Pole is really near the South Magnetic Pole. Um, all right, I'll find a picture real quick. Earth magnetic field. Okay, so let's find a better image. Okay, ooh, here's a NASA picture. It's taken forever to show up. Okay, so you guys can hopefully see this. Um, so the core of the Earth is deep in there, and the magnetic field it produces more or less makes these lines as if the Earth were a bar magnet. And again, since our compasses point north in this direction, despite what it says here, this is actually the south magnetic pole because our compass, the north end of our compass, points towards it. Um, and as you can see, the north magnetic pole, or the magnetic pole near the North Pole is not the magnetic pole near the geographic North Pole is not in the exact same location. Um, yeah, these are complicated topics to talk about near the end of the evening when I'm not really prepared to talk about them. Um, but yeah. All right. So I think I really am done for the night. If you're interested, I try to make YouTube videos every Wednesday, and I usually try to make them kind of short, like 10 to 30 minutes tops. And I try to keep them on a single topic. So that way, if you want to know what is the flat versus globe? What does the globe model say in response to this one flat Earth argument? I try to make videos that are short and to the point about a single flat Earth argument. So, for example, flat Earth says that the Earth is not a sphere, or that the moon is not a sphere. And I have a video showing evidence to support the globe claim that the moon is, in fact, a sphere. Um, anyway, um, I presume I'll make some kind of video tomorrow. I don't know what the topic will be. I don't really have one in mind. Um, but anyway, thank you again for showing up. I'm sorry Josh didn't show up. His name again is Josh Walker. You can look for him on YouTube. He's UberFlatEarth, also Josh Walker. You can find his videos. And Sean G, the universe is flat because your mom sat on it. Good night.